Have you ever wondered how solid rock can transform into smaller pieces, paving the way for soil and new landscapes? It is a fascinating process driven by natural forces, some obvious and some surprisingly subtle. Root wedging and frost wedging are both powerful forms of mechanical weathering, breaking down rocks without changing their chemical composition. While their goal is the same, they differ significantly in their agents and the conditions under which they primarily occur, shaping distinct patterns in the Earth's crust. Frost wedging, also known as ice wedging, operates when water seeps into rock fractures and then freezes. As water turns to ice, its volume expands by approximately 9%, exerting immense pressure on the surrounding rock, which can be up to 2,100 pounds per square inch. This repetitive freezing and thawing cycle gradually widens cracks, eventually breaking the rock apart. It is most effective in environments where temperatures frequently fluctuate above and below the freezing point, often seen in temperate, alpine, and polar regions. Root wedging, also called root pry, involves the physical force of plant roots growing into existing cracks and joints within rocks. As these roots thicken and expand over time, they exert pressure that pries the rock apart, much like a natural lever. This process is prevalent in vegetated areas where plants, from small shrubs to large trees, establish themselves on rock outcrops or cliffs, slowly but persistently enlarging fissures. It highlights the profound geomorphic influence of biological activity on the landscape. Distinguishing between their effects in the field often comes down to context and the resulting rock fragments. Frost wedging typically produces angular, blocky debris, often forming talus slopes or scree fields at the base of cliffs, and it does not necessarily requiring the immediate presence of vegetation. Root wedging, on the other hand, is usually identified by the direct observation of roots within widened cracks or by the presence of fractured rock clearly associated with a plant's growth pattern, producing a more irregular fragmentation near living flora. Understanding these subtle differences helps geologists interpret landscape formation. These two processes, though distinct, frequently work in concert, contributing to the broader process of denudation, which is the overall lowering of the Earth's surface. A rock fractured by frost wedging might later be further broken by plant roots, and vice versa. Both mechanisms are crucial in the initial breakdown of bedrock, leading to the formation of regolith, the loose, inconsolidated material that covers solid bedrock and is the precursor to soil. Appreciating their individual contributions and combined power offers a deeper understanding of how our planet's surface is perpetually sculpted by natural forces.